I'm going to start, then I'll hand over to David, and then I'll finish up. I'm going to say a few words to begin with about wealth and the nature of giving things away under the laws of physics. First, let's dispel an illusion. Wealth and money are not the same thing. You can sometimes convert between the two, of course, the blue arrow, but they're not exactly equivalent. For example, if you have a garden and you grow your own vegetables, you've created some wealth that wasn't there before. You then eat them, and that wealth has given you some benefit. No money has changed hands. As I say, you can sometimes convert between the two, but wealth and money are not the same thing. Wealth is stuff. Money is merely a way to get to stuff, or a way of turning stuff from one type into another. Now let's look at giving things away. The idea of giving away your primary product is something that's been around in the software industry for a long time, of course. You never paid for a search on Google, yet Google is one of the world's biggest companies, makes a great deal of money, as you know, and they make money by giving away their primary product. Linux, of course, completely free. Anybody can have a copy of the Linux operating system. It's running on the computer that's displaying this for you now. I didn't pay a penny for it. Firefox, the web browser, again, completely free. But all these organizations and companies, in some cases, in the case of Google certainly, make money. And the reason they make money is that they do things on the side of giving away their primary product. Now let's look at that model when it comes to harder things than pure information. We're all aware of the conservation of matter and energy. This is an experiment that I'm sure many of you did at school. You do a chemical reaction, and the result of the chemical reaction is different stuff than you started with, but of course it weighs exactly the same, and that's the law of conservation of mass, and we have a similar law for conservation of energy. Of course, in Einsteinian terms, you can convert between the two, but they're still all conserved. Just move my microphone a bit a minute. But that doesn't quite hold for information. You can take a pattern of ones and noughts, that is to say, you can take some information, and you can make a copy of it free. Now, any astrophysicists in the audience are going to argue with that. It's not entirely free, of course. Thermodynamics and quantum mechanics insist that you expend a certain tiny amount of energy in order to copy a bit of information faithfully. But from the perspective of the human economy, copying information is essentially free. You can make as many copies of it as you like. So that's the reason why you can give information away, and if you can then figure out a way of making money on the side, you've got a potentially successful model for succeeding in the world. But you can't do this with matter and energy, because when you give some matter away or you give some energy away, you haven't got it anymore. If I have 5 apples and I give you 2, then I've only got 3 apples left. If I have 5 bits of information and I give you a copy of that information, I've still got the 5 bits of information. But now, of course, information makes matter. That stream of ones and noughts is a CAD design, and when we've got that CAD design, we can use it to make a real physical object, as illustrated on the right there. So we now have a potential mechanism for giving away information, possibly making money on the side of giving that information away, and then having the end users, possibly even private individuals, supply the matter and energy that's needed in order to turn that information into useful wealth, useful goods. Okay, that's some preliminary remarks. We're now going to say a few words about the Arduino and about the RepRap project specifically, and then we'll come to a conclusion. David, over to you.
Thank you. So my name is David, not David, just have to point it out. As it was mentioned, I'm one of the co-founders of the Arduino project. I don't know if you're familiar to this project. The Arduino project is a prototyping platform. It's aimed at people that have no idea on electronics or software, for that matter, to start with digital electronics. And you might think that it's a crazy idea in the first place, and but well, it comes from the idea of teaching industrial designers on the craft of electronics. As you know, more and more of the everyday objects we have are commanded by digital electronics. And industrial designers, they are facing the issue of having to design something that is much more than just a box and a bunch of buttons. And they need to start thinking about the logics behind it and how things can be controlled and which kind of things will happen when something is connected to a data source on the internet and so back and so forth. So back in 2005, together with a colleague of mine, Massimo Bansi, who is also co-founder of the project, we're discussing about how to make a very cheap prototyping platform that could be brought to design students. And I mean, I'm a microelectronics engineer, what I studied at the university. And Massimo had several experiences in the business as well. And we came out with the idea of, like, if the electronic parts cost 20 euros, why should a prototyping platform cost 1,000 euros? That was definitely a stopping point when trying to learn about something. So we made Arduino with the idea of being as cheap as a textbook and trying to bring everything around it for free to those that were learning. This was challenging very much the market of prototyping platforms at the time. So we made this board, and just to give you some facts, this particular design, it's been manufactured 250,000 times and been sold around the world. Over 150,000 times just last year. So this is the thing we're talking about. We're talking about that we designed something that is supposed to be a specialized tool, and we introduce it in a completely new market where nobody else has been before. And on top of that, we made everything open source. You know, the board design is open source, the software is open source, the documentation is for free and available at our servers. This was a very challenging concept. So the Arduino platform is not just a piece of hardware, it's the hardware, of course, but it's also a piece of software that is cross-platform and allows people to start using this thing. There is a fact, and industrial designers, they mostly work with Macintosh computers, for good or for bad. And they run Mac OS X, for good or for bad. And prototyping platforms, they're usually working in Windows, and just recently started to work also in Linux. So when we were creating a prototyping platform, we had to focus on our user group that was people using a Macintosh. So we had to develop all this ecosystem of tools that had to be cross-platform from the beginning. So our IDE that you see up there is a simplified way of entering into coding for digital electronics. It's made in Java, and it's very easy to use. The program that you see up there is basically configuring a pin as an output, and then turning a pin on and off at a pace of once per second. And then, as I said, we offered also the whole documentation for free in the form of a website. 5 years later, today, there is more than 30 books that talk about Arduino that you can purchase. But what people don't know is that most of the information from those books comes from our website. People come to our website, they take the Creative Commons documentation, they make books, they add some stuff to it, and they sell it. But the most important factor for us has been the community. I mean, we created content for non-technical people, and those people embraced it because they could understand it. We were talking their language. And that brought more and more people to the point that right now, I doubt there is a university in the developed world that is not using Arduino boards as part of one or more education systems. So this is our growth. During the last 3 years, I've been responsible for running all the web services behind Arduino. I have to say, Arduino, until now, is a 5-man operation. And this is the amount of hits in our server. By January 2011, we had reached 45 million hits a month. I haven't taken the time to compile these statistics as for today, but I can tell you so much more. And I have to tell you, I cannot show you data of the sales of Arduino boards. Arduino is not selling boards. The Arduino project is just creating the IP, making reference designs, and licensing that logotype there. So if we make any money, it's by people putting our logotype on their circuit boards, and they pay us back for that. But I can tell you that there is a very close relationship between this curve and the sales. So you can get an idea of how we are generating cash flow in a company only based on IP. This is, as I said, the community is the most important thing for us, and all the community is mostly driven by, first of all, mouth-to-mouth communication. We haven't spent $1 in advertisement until now. And second, using the web as a communication media. And this graph here is a compilation of 5 years of data on the different participants coming from different continents. Green represents North America, yellow represents Europe. Orange represents Asia, and the other continents, unfortunately, they could be perfectly disregarded. But what you see here is how the maker culture that started in the US some years ago was very much taking the lead in our community. Most of the people that were coming to our servers were coming from the US and Canada. But something happened in 2008 that provoked an explosion in so-called the European scene, to the point that right now, from every 100 users, 40 are coming from Europe. And well, I can actually tell you what happened. I don't know, are you familiar with the Wired magazine, the American publication? I mean, the interesting thing is that if you ask around to the average person, they don't really know about Wired magazine. It's actually hard to get in some countries, like for example, Spain. Italy has its own version of Wired magazine in Italian, because otherwise nobody will ever buy it, right? So the thing is that in November 2008, an article came out on Wired magazine in the US, and that article triggered, a response of the European media, and that triggered a response of the European market. You see, it's like a couple of months later, this American article provoked a response of in Europe. I mean, I always show this thing because for me it's very interesting to show how within Europe we have no leading force, so to say, in how we reference or where we look for information. We actually look at the States. And that happens for our project as well. So finally, I think this is my last slide. I just want to show you a couple of examples of the things that have happened during the last year. The last year has been very, very exciting for the Arduino project. And the first thing that happened was that Google decided to use an Arduino derivative board as their basic design tool for Android accessories. So if you want to design an accessory for an Android phone or an Android tablet, Google offers a reference design that is based on an Arduino board. So if you want to start designing your new controller for, let's say, your fridge, I don't know why you would be interested in connecting your phone to your fridge, but it's a classic example. You can use an Arduino board. You just plug it through the cable, and you can start controlling different features, reprogram your fridge, and then unplug. But they did this without telling us anything. Since our project is open source, they just went on, took the reference design from our website, they made their own thing, and suddenly on the Google I/O conference last May, they just announced this thing, and we had no idea. So it took us 3 days to make our copy up there to the right. On the other hand, we've been involved we're involved in collaborating with companies. As I said, we are a 5-man operation. It doesn't mean that we can't collaborate with big companies. So on the down right side, you can see a project that we've been developing over the last months together with Telefonica Research and Development. I don't know if you know Telefonica, but it happens to be the second telecommunications company in the world. And the research and development department approached us because they were interested in looking for ways to enhance the innovation scene around the machine-to-machine business. So we started collaborating in creating different tools that will allow people create new objects that will use the GSM/GPRS networks to create new business and new wealth for their company, of course. I mean, Telefonica's point of view on this business is as long as there is 1 byte going through their network, they're making money on our design. So, and just as a funny note, on the down left side, since Google made that accessory, somebody made something to work for the Apple devices as well. So if you want to start developing an accessory, open source accessory for an iPhone, you can buy that cable that costs $59 and get started from there. To close, this is what Arduino enables. This kid here, Sebastian from Chile, I mean, he's not the average kid. I mean, you can see he's wearing a Debian T-shirt, of course. But there is many kids like this kid that are the future of our industry, so to say. And he developed an earthquake detector that is using an Arduino Ethernet board there, and is posting directly to the internet whether there is an earthquake alarm. And he's tweeting about the machine is tweeting about earthquakes and has a couple of thousand followers just for that. So this is what our technology does. It just empowers people to do things. I give the
Thanks, David.
floor back to Adrian.
Presenter tennis. Bat the ball to each other. Yes, I said I'd say a few words about RepRap, following on from the Arduino. The first thing to say about RepRap is that it's based on the Arduino. The microcontroller in the RepRap machine is an Arduino microcontroller. There's a picture of it, and in fact we've got a live one over there, which when we started speaking, started to print out a part. It's a 3D printer. But the important thing about it is not that it's a 3D printer, it's that it's a 3D printer that's designed to print out a significant fraction of its own parts. It's a self-replicating 3D printer. So not only can it make useful objects, one of the useful objects it can make is another copy of itself. Let's look at some facts. It can print out about half of its own parts at the moment, and the other half, equally importantly, are easily available to everybody. You can buy most of them, in fact, in an ordinary high street hardware shop, or in the case of the Arduino, which is its microcontroller, you can get that online, of course, anywhere in the world, similarly with the motors and so on and so forth. So anybody who has the parts that the machine can print for itself can easily make a machine, because there's no restrictions on any of the other components. Cost of all the bits and pieces to put one together is about 400 euros. When we started this project, 3D printers were really expensive things. The cheapest one that you could buy would be about 20,000 euros. And then we came in with this thing at this price, and that caused a few eyebrows to go up. And indeed, subsequently, a number of companies have set up to use the RepRap technology to make 3D printers that don't copy themselves. And I'll come back to that in a minute. Working volume is about 200 by 200 millimeters by about 140 high, so that's the largest object you could print. The materials it'll work with, most thermoplastics, though by far the two most common plastics that are used in the machine are polylactic acid, which is a biosourced biodegradable plastic, and ABS, which is the plastic that Lego bricks are made out of. Print rate, the speed at which it can lay down material, just under 20 milliliters per hour. And at that rate, a single machine takes about a day to print out a set of parts for another copy machine. So it copies itself slower than a bacterium, faster than a mouse, if you want a biological scale for that. The most important non-technical aspect of the machine is that all the information is given away free. In fact, we distribute it under the GPL. So anybody can download all the CAD files, both for the electronics and for the mechanics of the machine. All the documentation is also free. It's available to everybody. Of course, the GPL obliges anybody who uses the design and then improves it for themselves to release their improvements under a compatible license. And many people do this. But not everybody. One or two people have taken RepRap technology and built non-replicating printers, as I mentioned earlier, using that technology, and they haven't actually released all their designs. I don't care about this at all. I'm certainly not going to set lawyers on them. And the reason for that, of course, is that every 3D printer that can't copy itself can make RepRaps. So all of those printers are sterile with regard to their own species, but not with regard to mine. All of the non-replicating printers out there can build RepRap machines. And you can see what that does for the population dynamics, given that the RepRap machines can also build themselves. And that's the reason why I don't care about people taking the technology and making non-replicating versions of it. This is a snapshot of people using the machines. We invite people who build a machine to put a little lollipop on a map of the world. This was taken a couple of years ago, in fact, and it's by no means all of the users we had then, but it does give you some idea of geographical distribution. It's the geographical equivalent of the slide that David showed just now, showing the percentages of people in the world using the Arduino. And as you can see, the distribution is not dissimilar. Statistic about RepRaps, which is a little bit questionable because we don't know how many machines there are out there. We don't know how many people have built them. But we are reasonably confident that since 2008, which is the first point where the machine copied itself, and I'll come to that in a minute, there are now more RepRap machines in the world than there are conventional proprietary 3D printers that have been sold by the big 3D printer companies since the start of the 3D printing industry 30 years ago. And of course, we're growing exponentially, as is the nature of any object that can copy itself. What's the sort of thing that it can make? Well, one of the guys on the project, Zach Smith, who runs one of the spin-off companies from RepRaps, which is called MakerBot, and they incidentally do adhere to the GPL, they do release their designs. He started a website called Thingiverse where anybody can upload the design for anything, and I just went on there and downloaded some random things to show you. Top left, somebody cracked the drain in their shower tray, so instead of going down to the shop and buying a new drain at great expense, they just printed a new one and their shower now works again. Sticking with the bathroom theme, top middle, somebody's made a doorstop for their shower bath. The little bouncy bit in the doorstop is actually the end of a wine cork, but the rest of it was made in the RepRap machine. Top right, useful little stacking drawers for putting components in. Bottom left, a robot made by school children to teach them a little bit about mechatronics. The middle at the bottom is a slightly abstract object. It's a Saris linkage, which is a mechanism for obtaining parallel motion without sliding. And one of the guys on the project in Texas has been designing this with the idea of increasing that 50%, because it's essentially the RepRap machine is a Cartesian robot. It needs lots of parallel motion. This is a way of doing it with many more printed parts. And bottom right, children's shoes. The plastic used for those shoes is actually the plastic that they make milk bottles out of. And one of the things that we'd like to do is to design a shredder that the RepRap machine can make for itself, that you can put your milk bottles, or indeed anything else, into it, shreds the milk bottles. You then have a hopper in the machine, put the shredded plastic in, and it'll build with that. So you can make your own children's shoes. What's more, when your children's feet grow, which children's feet rather inconveniently do, you shred the shoes, throw in an extra milk bottle, scale the design by 1.1, and then you've got a new pair of shoes. This is perhaps one of the most spectacular objects that's been made in the machine to date. So spectacular, I've given it a name check. It was done by a guy called Michael Carey. It's a complete Gothic cathedral printed out in the machine. But, as I say, the most important thing philosophically about the machine is the fact that anybody with a RepRap machine can make another one and either give it or sell it to anybody else. And this is the very first replication. There's me on the left, as you can see there, and there's the parent machine beside me. That's actually the previous version of the RepRap machine, not the one that you can see on the stage here. And the guy on the right is Vic Oliver from New Zealand. He's another one of the people on the project. He made the machine on the right from the parts made in the machine on the left. May 2008 was the first successful replica. I say successful. In fact, when we put it together, it didn't work. The reason why it didn't work was because we'd made, nothing to do with the printed parts, we'd cut one of the drive belts too long. But we discovered when you put a screwdriver on it, it worked fine. So we just sat down, we designed a belt tensioner, we held the screwdriver against the belt, had the machine print out the belt tensioner, fitted it to the machine, worked fine ever since. So with self-replication, self-repair, and self-improvement sort of comes for free. So, back to the general theme, which is creating wealth by giving it away. If you open source the CAD for your product, anyone can make it. It's like having an instant mature market. There are no patents involved. Nobody's worried about intellectual property because everybody can copy everything around. It's just like making toothbrushes or the vast majority of chairs, the vast majority of any other product. You can't patent the idea of a chair. It's been thought of before. And of course, people make money by adding value. You can run a company printing out RepRap machines and selling the parts, and you can do it at a profit because people want them. But you get one really key, important additional thing that you don't get if you use a conventional model for making your idea and getting it out into the world. You get free input from 7 billion designers. Everybody wants to improve your device, and they submit their improvements online. You can adopt the best ones, and the thing can progress from just about working to working really, really well, very, very rapidly. If you're interested in either of the projects, or indeed both of them, those are the two websites. That's all that David and I have got to say. Thank you very much indeed.
We've got time for a couple of questions, and I would ask anybody leaving, the buffet and restaurant is not open. I should have let them go, shouldn't I?